A custom AI chip went from idea to first silicon in 9 months. That normally takes 2 to 4 years. And here's the kicker. An AI wrote most of the chip, not humans. AI designed the hardware it would eventually run on. Then they turned it on. And in the first month, a coding agent was already running on it. This is Jalapeño, OpenAI's first in-house inference chip, co-developed with Broadcom. And yesterday at Hot Chips 2026, they showed everything. The architecture, the performance numbers, and the uncomfortable part for Nvidia. Let's be honest about something. OpenAI is late to this party. Google has been shipping TPUs for 10 years. This is Generation 7. Amazon has Trainium. Microsoft has Maya. Meta has MTIA. Grok exists. Even Anthropic announced chip co-design recently. So the question isn't who built a custom chip first. The question is, what happens when the biggest AI customer stops buying? Because Nvidia's margin on AI GPUs is extreme, and every big lab wants out of the Nvidia tax. Jalapeño is OpenAI's vertical integration play. You build the model, you build the chip, you build the software, and you stop paying someone else's margin on the most expensive part of the stack. The architecture is weird on purpose. It's a NUMA-style design. 64 core slices. Each one gets its own HBM4 slice, directly attached. No unified memory, no conflicts, predictable latency. That's the whole point. You don't fight over a shared pool. Every slice knows where its data lives. The chip has 2 networks inside it. One is a collective network. Data moves register to register, zero contention. The other one is deliberately anemic, a general network for everything else. They starved it on purpose, because inference doesn't need a fancy general NOC. It needs the fast lane to be perfect, and the slow lane can just be slow. And the specs, 216 gigabytes of HBM4, 15.4 terabytes per second of bandwidth, 700 watts, 13.4 MXFP4 petaflops, clock speed of 1.70 gigahertz, plan to hit 1.80. Scale it up and it gets nuts. 128 chips per rack, 2,048 chips per pod. That's 27 exaflops, 432 terabytes of HBM4, and 32 petabytes per second of aggregate memory bandwidth. Broadcom Tomahawk 6 switches tie it together. Celestica does the assembly. Here's the real design choice. OpenAI splits inference into 3 phases: prefill, draft, verification. Nvidia does 2. Prefill is compute-bound, draft is latency-bound, and verification is bandwidth-bound. Most people build specialized chips for each. OpenAI built one balanced chip that does all 3, which means you never move KV cache between peers, and that saves serious power. And the fun part, AI designed this thing. The RTL work started in February 2025. Tape-out was November 2025. First silicon in May 2026, and that same month, Codex was already running on it. Codex is OpenAI's own coding agent, so an AI coding agent ran on a chip that AI helped design. More than half the core is written in XLS, that's Google's hardware language, not handwritten Verilog. OpenAI's own models found the optimizations. A BF16 multiplier got 56% better. An FP4 dot product got 21% better. The FP32 accumulator got 10% better, and the area shrank 8 to 10%. The AI even fit circuitry into a floor plan block where humans said it wouldn't fit, which is either impressive or slightly terrifying. Now the numbers, and you have to read these carefully. SemiAnalysis ran their InferenceX benchmark, normalized per watt against Nvidia's GB200 and GB300. Jalapeño delivers 1.5 to 1.9 times higher throughput per watt, 1.7 to 3.6 times lower end-to-end latency, and 2.1 to 4.1 times lower minimum time between tokens. Those are real. Then there's the marketing number, 104.3 times higher throughput at Nvidia's lowest latency point, which is technically true, but it's a methodology frame. They picked the point where Nvidia looks worst. It's inflated. Don't quote it without the asterisk. And here's the catch. Nobody on stage said out loud. On raw compute, Jalapeño loses. Blackwell Ultra does 10 FP8 petaflops, 20 NVFP4 petaflops per GPU. Jalapeño's win is per watt and latency, not brute force. The real flex is the 128 chip domain, over 1 petabyte per second of HBM4 bandwidth. GB200 NVL72 does 576 terabytes. A 1 trillion parameter model in FP4 is about half a terabyte. So theoretically, you could read the whole model 2,000 times per second, and multi-token prediction could cut latency another 3 to 5x. So why does this matter? Two reasons. First, the Nvidia tax. CNBC called this a direct threat to Nvidia's margins. When your largest customer builds their own silicon, your pricing power has a ceiling. And OpenAI is not a small customer. They are arguably the reason Nvidia's data center revenue exists at this scale. Second, the software problem. Jalapeño has no CUDA. You program it through low-level Triton. Software has to explicitly place tensors across the chip, and AI does the placement and scheduling optimization, which sounds elegant, but here's the trade-off. Nvidia code for Blackwell, it runs on Rubin. It runs on Feynman. No changes, same code. Jalapeño code has to be re-optimized every generation. That is the real moat Nvidia has, and OpenAI knows it. They just decided the per watt and latency gains are worth paying that cost. Jalapeño is not the fastest chip. It's not the first custom AI chip, and its software stack is the weakest part. But it's the first chip where AI designed the hardware it runs on. In 9 months, and Generation 2 is already heading to tape-out. Generation 3 is, according to Richard Ho, already operational. He actually had to correct his own slide on that. The slide said planned. He said no, operational. Jalapeño isn't about beating Nvidia today. It's about not needing Nvidia tomorrow.